Alright, as the homework 2 requirement, we don't need to change anything to do with the quadratic cost. So then we will just start modify from our cross entropy cost class. So the first thing we want to do is add our code for the derivative for our cross entropy cost. So this is a derivative function, and it will return to 0 when our output a equal to 1 or our output a equal to 0, and else it will return to this formula, which we can find from our lecture 3 notes. And then we want to add our log likelihood. So the first thing we want to add is our log likelihood function, which we can find from our page 12, lecture 3. So first, it will return the summation of this value when our target output y doesn't equal to 0, and else it will return to 0. So this we can find from our lecture notes formula. And then we will go through our derivative function, which when our our desired output y equal to 0 or our output equal to 0, it will return to 0, and else it will return to a NumPy array, which we can find from our lecture formula too. And then we want to add our activation functions on our tangent, ReLU, and also softmax. So first thing, we want to write the tangent and define the tangent function, which when our target output is equal, which is our tangent, it will return to this formula, which we can find from lecture 3 and page 33. So I'm not going to explain it because this is basically right from that formula. And the derivative function, it will return to this. It will return to a vector of this, which is 1 minus our target output power 2. And then we want to write our ReLU activation function. So first is the ReLU function. So our z will return to z when our z is greater than 0, and else the z is less or equal to 0, we will return 0. And also for our derivative of the ReLU function, our z will return to 1 when our z is greater than 0, else z is less or equal to 0, it will return to 0. So this is really simple. And then for our softmax, because the derivative function is already given, so the only thing we want to do is to add our softmax vector z, our softmax function. So first, we can see from our lecture 3, page 35, the formula. So it will basically just return, this is basically right from that formula. And also we want to add our another defined function, which we will use later in the regularization later. So we need to define our sine function for our regularization, so which we can find from our lecture 3, page 19. So as we can see, when our sine is equal to 1, when our weight is greater than 0, and also when our weight is less than 0, we will return, our sine will return to negative 1. And if the sine if the weight equal to 0, it will return our sine to 0. So basically this code is explain what I said before. So we want to return the -1 when our weight is less than 0, and else return to the weight. And when our new weights greater than 0, we'll return 1, else we'll return to this W1, the width 1. So after defining this function, the sign function, we will go back to our update mini batch function. So here, this is what we want to add, is the regularization. So first, we can see from our lecture 3, when for the weights update rule, especially for the actual return for our weights. So when there's no, we don't want to add any penalty, so our regularization will return this formula without any penalty. And if we want to update our weights, especially we can see from the backprop algorithm, we want to use the L1, then we will update our weights. So basically this is right from the formula from the lecture notes. And also when we want to use the L2, we'll update our self weights, basically right from that formula too. And also we want to update our total cost function. So when the regularization without any penalty, we will just pass. And when the regularization is L1, we update our cost, which you can see from the page 19. And also it will return update the new cost when the regularization is L2.